Hello and welcome to Capital Market in the Security Analysis for Ethiopia. In the previous, we have started to see mathematics for capital markets. Under that, we have seen time value of money or time value as a whole. And this is a continuation of the previous one. Today, we are going to see a present value of single sum. We have started to see different exercise. In the today we will see the left one. On this exercise, Beckham needs to have $25,000 in 4 years. What amount must he invest today if his investment earns 12% compound quarterly? Our given one is future value, that is $25,000, and the year is maturities, or the total year is 4 years. And what we are going to calculate is present value of today, and our interest is 12% compound quarterly. This means in a year the interest is paid 4 times, so that we have to calculate our n value, that is n equal to 4 times 4, that is 60 years. Our n value is 16, and our I value is 3, because I is equal to 3 r over the period, that is the quarter. It is 4. 12 divided by 4 becomes 3%, and then we can calculate our present value by using different mechanism. For example, present value equal to future value over 1 plus r the power of n. That is, our value of future value is 25,000 over 1 plus 0.03 the power of 160. Totally, the present value of this one become around 50,579. If you use a formula directly, we can get by using this formula, or also you can calculate by using present value of a single sum table. First of all, we have to find present value of factor value of present values, which is equal to 1 over 1 plus I the power of n, or we can get by using 1 plus I the power of minus n, as you know before, and we can get the factor values. Then the factor value equal to 1 over 1 plus I is 0.03, the power of n is 16, 1 over 1.03, the power of 16 equal to 0.62317. This is our factor values. And then when we search our factor value on the page 16, we can get, first of all, the I value is 3 down, and the end value is 16. It match on this circled one, that is 0.62317. With this, we can get our present values. Present value is equal to future value times present value of factor, the factor value, which is 0.62317, then future value times factor value equal to $15,579. dollars. This is present value that our person or become should invest to get $25,000 at the end of 4 years. This is how can we calculate the present value of single sum. We can get it in two ways, or directly by using a formula or by using of a table forms, which is very easy. The second one is a single sum problem, solving for other unknown. Example, computation of numbers of period. Now let us search or let us calculate our periods, that is n values. Economic Village wants to accumulate $17,000 for a construction of Veteran Mountain in the town square. At the beginning of the current year, the village deposited, that is present value, equal to $47,811. Future value, that is $70,000, and our R is 10% interest compound annually. So our N is directly 1 because it's paid annually. How many years will it take to accumulate 70,000 in the memorial funds? So what we are going to calculate is periods, that's N. So how can we get N? We can get in different ways. By using of formula, we can get in the form of present value approach or future value approach. For example, a future value approach equal to present value in the brackets 1 plus I the power of n, or present value approach equal to future value over 1 plus I the power of n. Then our n values, when we calculate using the future value, our future value is $70,000 equal to present value is $47,811 times 1 plus our I value is 10%, that means 0.1, that is 0.1. The power of n is, our n value is n. What we are going to calculate is n. Now 17,000 over 47,811 is equal to 47,811 over 47,811 in the times 1.1 the power of n. Then this become 1, that is 47,811 over 47,811, that is become 1. Now 1 plus, or 1.1 the power of n is equal to 17 over 47,800, which become 1.76, something like that, and then our value for future value factor is around 1.4, or we can get this one by 1.1 the power of n is equal to 1.76 and the like. Then we have to make 1 over n, or we can make we can use different mathematical formulas. We can get by this also, or directly we can find the future value factor equal to present value times future value factor. Future value is equal to present value in the bracket future value factor of n 10 times or 10%, Then $70,000 is equal to 47, that is present value, and 811 times factor values. Then when we divide 47,000 in both sides, we can get factor value equal to 1.46410. This is our factor using the feature value factor of 1.46410. Refer to the table 1 in the read down 10% column to find the factors in the 4 periods. Now, when we search at 10% down column, then we get 1.46410 at the period of 4. At the period of 4, we can get by going down and also by going horizontal, we can get n periods. So the value we are going to search is 4. Our n is 4. So in this way, we can get our ns or a period or a year. This is one method. This is feature value approach. And also present value approach. Our present value approach, in the formula also we can get present value equal to feature value over 1 plus I the power of n. In this way also we can get present value approach. Our present value approach. Our present value approach is present value equal to feature value times present value factors. Then $47,811 equal to $70,000 in the brackets present value factors. Then when we divide $17,000 in both sides, we can get 0.68301. This is our present value factor. Our present value factor of 68301, by referring our table below and read down the 10% column to find the factor in the 4 period now also. Going down in 10%, going down, we get our factor values. A present value factor value 0.68301 is found at 4 period. So we have confirmed that in feature value approach and the present value approach, our period is 4 or our year is 4. So we can calculate our years or periods by using in these 3 ways. One in the direct formula ways, or by this factor approach. That's present value approach as well as a feature value approach. We can get easily in this form. But if we need shortcuts, we can use a formula which is feature value equal to present value in the bracket 1 plus I the power of n, or in present value equal to feature value divided by 1 plus I the power of n, or feature value times in the bracket 1 plus I the power of n negative n. This is the way we can get in both ways. In 3 or 4 ways we can get our values to be 4 years or 4 periods. Example, computation of the interest rates. The present value is 800,000. The future value is 1,409,870. Our n value is 5. We are going to search or calculate for unknown one, which is interests. How can we get? By using a different technique, we can get by formula as well as also by table form. Then let us calculate by future value approach. Future value is equal to present value times future value factor at 5. Then our future value is 1,409,870 equal to $800,000 times future value factor. We're going to search for interests. Then when we divide $800,000 for in both sides, we can get 1.76234. This is future value factor, and then this future value factor of 1.76234 refer to table 1, the read across 5 periods row to find the factor. Then when we go into 5 periods and our interest is, our factor is find at in between 11% and 11% and 15%. This is interest rate in between this. We can get 12%. This is 1.76234 factor is find at 12% interest. So our interest is 12%. Or you can get by using of a formula. In the formula also we can get 12%, that is 12.001 by using of the formula. By using of the formula, that is present value or future value equal to 1 present value in the bracket 1 plus I the power of n. Then we have future value, we have present value, we have n. What we have not is I. So that is future value is 1,409,870 equal to present value is $800,000. 1 plus I the power of n. Then divide both sides 800,000, then 1 plus I the power of n, n is 5, equal to, that is 1.76234, then 1 plus I the power of 5. That means we can categorize, or we can calculate, or we can do 1 over 5 in both sides, 1 over 5 in both sides. Then 1 plus I equal to the root of 5, that is 1.76234 root of 5 minus 1, which become 12.00, some like that one, that is 12%. So we can get by using a formula also. Can get by using of formulas. By using the future value approach or present value approach, we can get by using our mathematical formulas. But in the table form, you can simply get as such if there is a table. If there is no table, you can use formula, direct formula. Future value equal to present value in the bracket 1 plus I the power of n. Then we can get our I values. Again, there is also present value approach in the same way. Now we have to search for present value factor. Our present value factor is calculated. Present value is equal to future value in the bracket, present value factor. Then we can divide it 1.4 million in both sides, or 1,409,870 in both sides. We can get the factor value, present value factor, which 0.5673432 or 743. Then using the present value factor of 5674.3 refer to table 1, the read across the 5 credit rows. We can get on the 12%. On the 12% rates, we can get our factor. Then our interest rate is 12%. So we have confirmed it in both sides. In both sides, we will confirm by present value approach and the future value approach. This is the way to calculate. Also, as we have said before, present value equal to, by using a formula, future value over 1 plus I is the power of n. Then we can get I by using this technique too. The next, see which formulas? By factors formulas. This one. R, that is regular payments, in the brackets, future value factors of ordinary entities. Future value of factors for ordinary entities is equal to 1 plus I is the power of n minus 1 over I. This is what we have discussed. This is a formula that provide efficient ways. Or also we have seen by using a table form. Then R is periodic rents, future value of ordinary entities, future value of factor of an ordinary entities, I, rate of interest per period, n, number of compounding period, how many times the frequency of payments. Future value of ordinary entity again, illustration, what is the future value of this 5,000 deposit made at the end of each of next 5 years, earning interest of 12%. If our statement said at the end, we're going to search for ordinary entities. Then by using the factor formulas or by using of our general formula, we can get future values. That is, a future value of an ordinary entity is equal to R, or regular payments, that is 5,000 deposit at the end of each for next 5 years, in the bracket factor values, that is 1 plus 12, that is rates R over 12, the power of 5 minus 1. Our factor value is 6.35285, and our future value becomes 31,764.25. Then we can get also by using of table. Look, how can we search using of table? Then our table shows a factor of 6.35285, and our deposit or present value is 5,000. Then present value times this factor become the future value of 5,000 times factor value. Then we can get present value of $31,764. This is also another way for finding our future value of an ordinary entity. Then future value for ordinary entity, the present value of is 0 at this time. Exercise, bio will deposit 30,000 in 12% fund at the end of each year for 8 years beginning December 31, 2010. What amount will be in the fund immediately after the last deposits? What table can we use? Let us see our table. Then our factor is 12.29. Then our factor is 12.29 by using of factor value. There our deposit is 30,000, the future value of $368,991. This is also how can we calculate that is easily. We can calculate using these formulas. The next one is future value of ordinary annuity. Again, illustration, competition of the rate. Illustration assumes that you plan to accumulate $14,000 for a down payment on condominium apartment 5 years from now. For the next 5 years, you earn annual return of 8% compounded semi-annually. This is our N is in the year, our N become 2. Frequency of payment is 2 times in a year. Then our time is, year is 5, 5 times 2 is 10, N is 10. Then our return, our rate is 8% if that is annually, but if that is semi-annual, we can divide it 8 by 2, that is 0.04, 0.4%. Future value of an ordinary entity is equal to regular payments equal to future value factor of ordinary entities at 10 periods, and for rents or for interest rates. Then our factor become 12% or 12.00611. Then we are going to find R. Our R is equal to 14,000 divided by 12.0061 become R is 1166.07. This is our R. Again, competition of rents, alternative calculation. We can calculate by using our formulas, and also we can get using our table formulas. Today we are going to see a present value of single sum. We have started to see different exercise, and today we will see the left one. On this exercise, Beckham needs to have $25,000 in 4 years. What amount must he invest today if his investment earns 12% compound quarterly? Our given one is future value, that is $25,000, and the year is maturities, or the total year is 4 years. And what we are going to calculate is present value of today, and our interest is 12% compound quarterly. This means in a year, C. Comparison of ordinary annuity with NTD. When we compare both ordinary annuities, at first there is no payment for ordinary annuity, but for NTD there is the payments. The payment at the beginning. For ordinary, it is at the end. Look how they are different. At the end, at period 5, interest for the annuity is 7.11519. For ordinary interest is 6.35 so there is a difference. Annuity is greater than ordinary annuities. Future value of annuity, computation of future value for annuity. Illustration: JJ deposits 2,500 today in saving account that earns 9% interest. He planned to deposit 2,500 every year for a total of 30 years. How much cash will JJ accumulate in his retirement saving account when he retires in 30 years? Future value of an ordinary annuity of 1 for 30 periods at 9% equal to 136.3075 times factor of 1.0.9. Then the future value of annuity of 1 for 30 period at 9% equal to 148.57 times periodic rents 2,500. The accumulated value at the end of 30 years is 371,438. This is how can we calculate the future value of annuity. And also we can use our normal formulas. We can calculate by using of our normal formula for annuity. We will see in the next more detail. For now, this is the end of today's program and I thank you for your views. Please, if you like, subscribe to my YouTube and share. Next time, we'll learn the future value of annuity and the present value of ordinary annuities and others. My YouTube is like this one. Thank you very much. Please give your comments